The human body is an incredible machine, capable of hoisting hundreds of pounds of raw iron directly off the floor. Yet, despite this massive capacity for strength, it can also bend, twist, and contort with fluid, effortless grace. From an engineering perspective, this is a glaring contradiction. If you want maximum load-bearing strength, you build a rigid, immovable column. If you need extreme flexibility, you design something more like a whip. Add to this a fact that this same structure has to safely encase the spinal cord, the most vital, fragile electrical wiring in your entire body. Your spine manages to balance all three of these contradictory demands every single day. But this incredible anatomical compromise creates some severe vulnerabilities. When we operate this biological machinery outside of its mechanical limits, we invite catastrophic structural failure and life-altering pain. To see exactly how it works, we have to look at the blueprint. The human spine is not a single solid bone. It's a continuous tower constructed from 33 individual vertebrae. This wireframe diagram shows how the design changes. At the top, 7 cyan cervical vertebrae support your head. Below, 12 magenta thoracic vertebrae protect your heart. Lower down, 5 massive yellow lumbar vertebrae carry your weight, finally anchoring to the orange sacrum. Between almost all of these vertebrae are intervertebral discs. Think of them as hydraulic, gel-filled shock absorbers. They compress and expand to act as cushions, preventing bone-on-bone friction every single time you take a step. And if you look straight down the center of these stacked bones, they're hollow openings perfectly aligned to form a secure, armored canal. This is the central superhighway for your nervous system, safely routing millions of electrical signals from your brain to the rest of your body. The true genius of this system is how these stacked bones and hydraulic pads work together to dynamically distribute kinetic energy, all while keeping your neural network completely shielded. But everyday movements can easily bypass the shock absorption system if you execute them poorly. When you bend at the waist and round your back to pick up a heavy box, you completely disengage your leg muscles. This vector diagram shows the result. Rounded posture concentrates massive shear force onto the front edge of lumbar discs, pinching them backward. The extreme pressure ruptures the outer wall, causing a herniated disc. The bulging gel presses into the sciatic nerve, triggering severe shooting pain. Debilitating lower back pain is rarely random bad luck. It is a highly predictable mechanical failure caused by basic physics and user error. Because a herniated disc is a strictly mechanical problem, it can be entirely prevented with mechanical support and proper operating procedures. This diagram illustrates the first rule of spinal maintenance: redistribute the load. By squatting to lift and keeping a straight, neutral spine, you use your powerful leg muscles and bypass the fragile lumbar discs entirely. The second rule is to activate your internal brace. Strengthening your deep core muscles, specifically the transverse abdominis, creates a strong stabilizing corset that wraps securely around your lower back. The final rule is to rehydrate the hydraulics. Sitting continuously for hours compresses and dehydrates your spinal discs. Taking movement breaks every 30 minutes allows those pads to absorb fluids and stay resilient. If this breakdown gave you a better perspective on your own health, smash the like button and subscribe for more 3D anatomical deep dives. Your spine is a living, dynamic pillar. Respect its mechanical blueprint, and you protect your ability to move through the world.